Generic rectangles, finding factors. Recall that when we multiply expressions, like these binomials, using the generic rectangle, we like to write the answer as a sum. So recall, we're going to write the first term along the side and the second term across the bottom. And then just finding the area of each of the four squares. The area of this square would be x times x, which is x squared. The area of this square would be x times 7, which is 7x. The area of this square would be 3 times x, which is 3x. And the area of the upper right square would be 3 times 7, which is 21. And recall that when we do these, one of the diagonals will end up with like terms that we can add together. So 7x and 3x will be 10x. So our final answer written as a sum would be x squared plus 10x plus 21. Now the original question, that is the same area written as a product. So we need to be able to write our answers as a sum or a product. And remember, when we're doing sums, we always start with the x squared term first, the x term second, and the term without a variable comes last. Now, today's lesson, we'll be doing this in reverse order, where you will get the generic rectangle all filled in, and our goal will be to find what goes on the outside so that we can write that generic rectangle as a product. So, in today's lesson, we'll start with the sum of the generic rectangle and try to find the product it came from. First thing I want to do is just get the sum real quick. So for the sum, remember, we're going to write the different parts of this rectangle. So I get x squared. Remember, we do have like terms across the diagonal. So 7x plus 3x would be 10x, and then plus 21. So that is the answer as a sum. Today's goal is to write this answer as a product, which means we need to find what goes on the outside of this rectangle. So my suggestion is you first start off with the bottom left square where it has the x squared in it. And we know that the dimensions of that rectangle must be x and x, because x times x would give us the x squared. Then I need to figure out what would go here so that when I multiply x times this yellow rectangle, I'm going to get 3x. Well, I would need a 3, because x times 3 would be 3x. And then I do the same thing up here. I figure out what times this x would give me 7x, and that would of course be 7. So that goes here. So as a product, I'm just going to write the sides of this generic rectangle. So I'm going to write this side first, and that would be x plus 7. And then I'm going to write this side second, and that would be x plus 3. So there's my answer as a product. Now, I could have also written it in the other order, x plus 3, x plus 7. Both of those answers are equivalent, meaning that they are the same, and either one would be considered correct. Okay, so the order you write those factors in does not matter. Let's try another example. Again, I think you should start with the bottom left-hand rectangle first, and that's x times x. And then whatever I put here, when I multiply it times this x, I need to get 5x. So that would be a 5. And whatever I put up here in the upper left, when I multiply it by this x, I have to get 4x. So that would be a 4. So now my product is x plus 4 if I do the left-hand side first, and x plus 5 if I do the bottom second. And again, it doesn't matter what the order is I put these down in. And if I asked you to write this as a sum, all you would do is start with x squared, combine the diagonal-like terms, which would be 9x, and then add the 20. So you should be comfortable writing these generic rectangles as a product or a sum. Here's another example. Again, I'm going to start with x and x here. I need to get 6x in this square, which means I'm going to put a 6 here. And I need a 3x in this square, which means I'm going to put a 3 here. Now, one thing you can do just to double check that you did this correctly is take the 6 and the 3 and multiply them together and see if you get this upper right-hand box. And you do. 3 times 6 is 18. So that's just a way to check to make sure you've done this correctly. So now my product would be x plus 3, x plus 6, or again, I could reverse those, and I'm not going to write the reverse. I could write this as a sum, just to review that again. So it'd be x squared. I would add the 2 diagonals, which is 9x, and then 18. So again, you want to be able to write these as a sum or a product. Here we're introducing some negatives, and that's okay. Again, I start with the x squared box, which would be x times x. I'm going to write an 8 here, because x times 8 would give me the 8x. And I'm going to write a negative 4 here, because x times negative 4 would be negative 4x. Now, when I transfer these over, for the product, this one's going to be x minus 4. So notice the 4 was negative on the generic rectangle, and that turns into x minus 4 in the product. Okay, and then the other one would just be x plus 8. And again, I could write this as a sum, so don't forget that that's also an option. Here, the diagonal numbers are both negative, so it means I'm going to start with x and x. I would need a negative 5 on this side, and I would need a negative 2 up here. And if you double check and do the negative 2 times negative 5, you do get positive 10. Okay, so this one does work. So the product would be, now both of these have a negative. They have negative 2 here and a negative 5 here. So when I write the products, those turn into x minus 2 and x minus 5. And again, does not matter the order you do those in. Those are equivalent. And remember, we could write this as a sum as well. It would be x squared. When I add negative 2 and negative 5x, that's negative 7x, and then plus 10. So be sure you can write these as products and as sums. Now, the last twist is that we can put a coefficient in front of the x squared term. So this is a 2x squared. So I'm going to write an x and an x, but x times x is just x squared. I need to put the 2 in there as well. And your choice of the 2 depends on which one can I multiply by a whole number to get, or an integer to get, like in this case, the 3, or in this case, the 10. Well, it's really hard to multiply 2 by a number and make it be a 3. Okay, I can't do it with an integer. It would have to be a decimal. But I can easily multiply 2 by 5 to make 10. So I'm going to want to stick with this 2 on the bottom, and I'm going to erase this 2 here. Okay, now x times 2x gets me this 2x squared. So that's always my first goal, is to get that x squared box taken care of. Now I just say, all right, how do I get 10x in the upper left-hand box? Well, it would be 2 times 5 makes 10. And how do I get a 3x over here? I would put a 3. So my product would be going down the left side first, x plus 5, and then going across the bottom, 2x plus 3. Okay, so the trickiest part of this is to figure out where to put the 2. Okay, and the way we want to look at it is, will the 2 go into this number evenly, or will it go into this number evenly? And whichever one it's going to go into evenly, you're going to put it in that row, okay, or that column in this case. Let's do another one like that. This time I have a 3x squared. So again, I'm going to start with x and x. I need to figure out where to put the 3. If I put it here, it's going to be very difficult to find a number here to multiply to be negative 2, because 3 does not go into negative 2 evenly. But if I put it here, 3 does go into 12 evenly. It goes in 4 times. So that means this will be a 4. And then I can put a -2 here because x times -2 is -2x. Again, you could check that 4 times -2 gives you -8, and it does. So I am correct. So my product would be x plus 4, 3x minus 2. And to show you the sum one more time, remember, we would go 3x squared. I would add the 12x and the -2x, which would be 10x, and then minus 8. One more example. Here I have a 3 again. So I'd put an x and an x. If I put the 3 here, 3 does not go into 4 evenly, so that's not a good location. But 3 does go into 21 evenly. So I would put a 7 here because 3 times 7 would give me that 21. And I'd put a 4 here because x times 4 gives me 4x. And then double check the product. 7 times 4, that is 28. So I am good. So now as a product, it would be x plus 7, 3x plus 4. So good luck with finding the product for generic rectangles.